Okay, so the absolute value of negative 4 is 4, because absolute values are distances away from something. Okay, so think of this as a distance from 0. Negative 4 is 4 spaces to the left of 0. Okay, so the distance is 4. Okay, number 2. Yasmin, what'd you get? 2. Okay, so you're going to do order of operations. You're going to do inside the parentheses first. And that's going to give you the absolute value of 2. And the absolute value of 2 is 2. Any questions over there? Okay, number 3. Nate, what'd you get? 4. Very good again. You're going to subtract negative 6 and 2, which gives you the absolute value of negative 4. And then the absolute value of negative 4 is 4. Any questions over that? Okay, then we need to talk about, okay, Jill, she likes to run. Okay, so she's going to run to the park and back to her house each morning. The below graph represents her distance from the park over time. We want to write down 3 things we notice about this. Okay? Does anyone have something they notice? Yes, great. Oh, good. Okay, it took her 40 minutes to get to the park and 40 minutes to get back. Diane, did you notice something else? It's their symmetry. They have symmetry right at 40. Okay, anyone else know something about where I go? Has a slope? Ooh, let's check. Okay, so it goes down 1, but how far am I moving to the right, actually? 8. Okay? So a slope of 1/8. Okay? Okay. Most people thought it was 1-to-1, but you have to check that because we're counting them a little bit different. Okay, go. Has the right angle? How do you know? It just looks like a right angle? How do you know? Because it looks like it, right? Okay, so you know how to prove it? Yeah? Huh? Yes, she went to the park and left, which is what it states in the problem, right? Yeah?
From her house, or wherever she started, like 5 houses in front.
Okay. She lives not 5 miles. What are we doing with? Kilometers. 5 kilometers. It's about 3. It's a little over 3. Yes. Huh? The root of 40? The x value is 40? Is that what you're saying? Okay. What do you, because it goes to 80. Or are you talking about the intercept? Okay. The x-intercept is 40, yes. We're running out of room here. Okay?
It goes down and back up.
Good. Because we went, right, this shows us getting This is distance away from the park, so we're getting closer as we're running to the park. Closer, 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 closer.
Oh, she gets.
And now we're at the park, so we're 0 miles or kilometers in this case away from the park, and then we're going to run away from it to go back home. Yes.
She runs 8 kilometers. 1 kilometer in 8 minutes.
Okay, she runs 1 kilometer in 8 minutes. That's good. That's No. 1 kilometer. 3 kilometers. Sorry, 5 kilometers is almost 3 miles.
Oh.
Okay? I don't know exactly the 1-to-1. We'll have to Google that at some point. Okay? But, so yeah, so she's running, takes her 8 minutes to run 1 kilometer. Okay? Any questions? Any other things?
It took her the same amount of time to get there.
Yes, she ran at a constant rate there and a constant rate back. She didn't speed up or slow down, so she has a very good pace. Okay? Okay, it's just the fan. Okay, so now we're going to write the piecewise function for that graph. Okay? So we're going to start by doing the piecewise function for this line. Here. If I can draw it nice and pretty. So for the first one we need the slope, which we already talked about, which was, it's going down, so it's negative 1/8. Okay. And then the y-intercept, where does it cross the y-axis, class? At 5. So that equation is just y equals negative 1/8 x plus 5. Then we need the domain. Diana, so that first line, where's my x value start and end?
0 to 40.
Very good. So 0 is less than or equal to x is less than or equal to 40. Okay, now I'm going to write the next one. That's not there. So for this line, our slope now is going up 1/8. So it's positive 1/8. Move it close to here. I don't know what the y-intercept is. It's going to cross somewhere down here. Okay, so we have to use a point. And I'm going to use that starting point of 40 for x and 0 for y. And we're going to plug it into y minus y1 equals m times x minus x1.
Wait, actually,
Mm-hmm.
wouldn't it just be magnified?
How do you know? It's a good guess, but I want to know how you know. Uh-huh. So you feel like it's just going to be mirroring this down here? Okay, let's check. Okay. You are correct. Okay, we're going to show the math for it. Okay. Okay, so we're going to do the y minus 0 equals 1/8 times x minus 40. Distribute. And I get y minus 0 is just y, equals 1/8 x. When we multiply by a fraction, we're actually just dividing. So 40 divided by 8 is what, class? Minus 5. Okay. And then we need the domain. John, what are my x's between? That was for this one. We're talking about the red one now. 40 and 80. I don't put a line underneath it because it can't equal on both of them. It can only equal on one of them since the 40 repeats. Okay. So then we'll write the whole thing out. F of x equals the negative 1 over 8 x plus 5. And then the domain of 0 is less than or equal to x is less than or equal to 40. And then the domain of the equation of 1/8 x, not plus 5, minus 5, with the domain between 40 and 80. Any questions over that? We're all good? Okay. Now we're going to show you how to graph an absolute value equation, okay? Absolute value equations are very similar, or can be written as a piecewise function, so that's why we're doing them together. So we're showing the similarities between the piecewise and the absolute values. So let's just start with your basic equation of a line. Your basic equation of a line is f of x equals x. So your all x values are equal to your y values, your f of x values. Okay, so when x is negative 2, y is also going to be negative 2. When x is negative 1, y is also going to be negative 1. When x is 0, y is also going to be 0, 1, and 1, and 2, and 2. Any questions over that? So we have negative 2 and negative 2. We have negative 1 and negative 1. We have 0, 0. We have 1, 1. And we have 2, 2. So this is our line. That's just the graph of f of x equals x. Now we want to graph the absolute value of x. So all the things that's going to change is now we'll take the absolute value of all of our numbers. Okay? So we want to know this. When x is negative 2, what is the absolute value of negative 2? 2. When x is negative 1, what's the absolute value of negative 1? Absolute value of 0. Absolute value of 1. Absolute value of 2, 2. Okay? So now, when x is negative 2, y is going to be positive 2. When x is negative 1, y is going to be positive 1. X is 0, stays 0. 1 is still 1, and 2 is still 2. So if you look, all it really did was take these negative values and flip them up. And said, nope, you can't be negative. Okay, so this is the graph of an absolute value. Any questions over that? Okay, what do you notice about the above absolute value graph? What are the graph's characteristics? So everybody write down what they notice about that blue graph of an absolute value equation. It's about the graph.
I noticed that it overlaps the line.
Okay, so it kind of coincides with the linear equation.
Yeah.
Okay, at some points. Kyle, what did you notice? It has symmetry. Okay. Through the lowest point. Okay, if I fold it along that lowest point, it'll have symmetry. Oscar, what did you notice? What shape is a quadratic? It's a U. Is that a U? No. What is that shape? It's not linear. What shape is that V? Or what shape is the blue line? It's a V shape, okay? So absolute values will be the V shape. Okay, does that make sense? Because parabolas or quadratics, they don't rise at a constant rate. They rise at that pattern rate of change of first up 1 over 1, then up 3 and over 1, then up 5 and over 1. This is rising at a constant rate of up 1 over 1, up 1 over 1, up 1 over 1, and it will do that. Okay? So all absolute values are going to be V-shaped. It's shaped like a V. And all absolute values will have that same shape. Okay, just like all quadratics are parabolas, U-shaped, all linear equations form lines, straight lines. Any other questions over that? Okay, let's look at the back. Now we talked about that piecewise function and absolute value functions. You can write an equation as a piecewise or as an absolute value function for that same graph. Okay, so below is a function written as a piecewise function and an absolute value function in its graph. Compare and contrast the two equations. So these equations are for the same graph. You can just write it either way, however you choose to write it. Okay, so I want you guys just to write down what you noticed about the two equations. How are they the same? Okay, Marissa, what did you write? What was something that you saw? You noticed about the two equations? Okay. Well, this isn't necessary because it doesn't have a domain, so we don't know if it has the numbers that are just less than 4. This has all the domain. It has everything here that's graphed. Okay? It just includes both of these equations in one equation instead of having two. So the absolute value has one equation, and the piecewise would have two. Anthony, what's something you wrote down? Okay, well, let's see. What do you think? What is similar about both of them? What do they both have? Even more specific. It has more than just 4. It has what? A negative 4. And what else goes with that negative 4? Right? They all have the same x minus 4, x minus 4, x minus 4. The x minus 4 and these are just in parentheses. These are in those absolute value signs, those bars. Okay, but they both have it. Okay, anything else? Anyone else notice something? Okay, let's call one more person. Lauren, what did you write?
I wrote what you said about them both having
X minus 4. Okay, we both have 4s in them. Okay.
What would it be like if that's
These two are kind of opposites of each other, right? Just like we had before on these equations. They were opposite signs. These were opposite signs. That's the same thing here because it has the negative outside. If I distribute it through, then this would be negative x plus 4. So they'd be opposite signs. Okay, those are the two piecewise functions. Okay, this is the one that we care about between these two. So you could just take what's inside the parentheses and put it in bars and get the absolute value function, right? Okay, so I want you guys to take this piecewise function and write it as an absolute value function. What would it look like if I wrote it as an absolute value function? Get that. Okay, so it should be f of x equals the absolute value of x plus 2, and then outside of it, plus 3. So just take the parentheses and change them to positive. And you only need one because this negative is to make this side here. The absolute values will make that line that should be going down like this flip up and go this way. Does that make sense? So that's why you only need one equation, whereas the piecewise needs two, because it needs one for after negative 2 and one for before negative 2. Any questions? Okay, let's do the next one. Now we're going to go from an absolute value equation to a piecewise function. Okay. You can do it more than one way. I'm going to show you just one way based on the graph. Okay, look at the graph and write the function that way. Okay, so we should have f of x equals that first line. We need the slope, which is down 1 over 1, down 1 over 1, down 1 over 1, and it crosses here at negative 1. So the m is negative 1, and the y-intercept is also negative 1. Any questions over that? So you get negative x minus 1 from the domain it starts at 2 and it gets smaller. So it has to be less than or equal to 2. Any questions over that? Okay, then we'll deal with this line. Okay, it has a slope of 1 over 1. Goes up 1 and over 1. Up 1 and over 1. So we have to extend it down to see where it's going to hit. And we hit here at negative 5. So the b value is at negative 5. So it would be just x minus 5 when I plugged it back in. And it then would have a domain of x has to be greater than 2. Again, you can't put a line underneath it because you don't want them both to have lines underneath. Okay, so only one of them gets a line, and you get to choose. Okay? It would be right if you put the line here and had this not underlined, but you just can't have them both have a line. And that's my graph, my graph written as a piecewise function. Ooh. Any questions? Okay. Okay. So you can answer that. How do you write these equations given the graph and in either the absolute value function or the piecewise function? You guys can write something down for that. Okay, so the first one on your homework is an absolute value. You can identify a slope and the vertex just by looking at this graph, or at the equation of the graph. If we look at this equation, you can find the slope. Does anyone know what the slope is here? 1. The number in front of x is 1. So your m equals 1 over 1. Then this is similar to vertex form of your quadratic functions. Okay? We can identify the vertex, the lowest point on this graph. Does anyone think they can find that vertex if it has parentheses squared around it? 3 and 2, right? Remember, inside the parentheses would be the twilight zone, so you change the sign. Same with inside the absolute values. When you see this, you just pull out the -3 and make it positive. So we're going to start at 3 and +2. Okay, then our slope is 1/1. So we're going to go up 1 and over 1, up 1 and over 1. What shape should this graph have? A V. So in order to make the other side, I have to go up 1 and left 1. Up 1 and left 1. Because they rise at the same rate, just going in opposite directions. And that's my graph. Any questions over that? Okay. This is the same thing. This is kind of written in vertex form. What would be your vertex for that top line? 3 and 2, right? It's still saying that was going to be going less than 3, so to the left of 3. And its slope to the left of 3 is -1/1. Okay? You don't want it to, on this one, to do it right, you're going to make the top number positive and then the bottom number negative. It still means this is a -1, but now you can do those numbers going this way. Going up 1, left 1, up 1, left 1. And those numbers now will make it negative. And be less than 3. The other side still has a vertex of 3, 2, but its slope is a +1. So it's going to go up 1, right 1, up 1, right 1. And those are all the numbers that are greater than 3. Any questions over that? Okay, so if you notice, all of these graphs will be V-shapes because they're all graphing absolute value functions. They're just writing them as piecewise as well. Any questions over that? Okay, you guys can work on your homework for a little bit.